Hello friend, in this video I will discuss how to derive average revenue productivity of physician under the Pauly Redisch framework. This is examination asked question for course code MEC 108 Economics of Social Sector and Environment. This question carry 12 marks. Okay. Pauly Redisch framework and Pauly Redisch present a model of hospital service in which physician, that is doctor, work as cooperative and it is based on certain assumption. You can see patient would receive two bill. One bill for hospital service and another bill for physician. Second, patient is a concern with total bill to be paid to hospital, and demand for hospital stay depend upon the price charged by hospital per day, and one thing, length of stay remaining fixed. Total price of hospital is denoted by P, first thing, and X is duration of stay measured in day. Therefore, P is the function of X. Total price of hospital stay depend upon the number of day patient stay in hospital. P include PH, that is the payment made to hospital, and physician. P include both payment. And assumption number 5, you can see hospital earn zero profit, pi equal to 0, and if it means zero profit means TR equal to TC, total revenue equal to total cost, and PH payment made to hospital, X is the number of day patient stay in hospital equal to W, where W denoting wage rate of non-physician labor like nurse, compounder, technician, pharmacist, etc. And L is the number, and that is number of non-physician labor engaged in hospital service. C is the price of capital. K is amount of capital engaged in hospital service. And last final assumption, total revenue is distributed between hospital and physician, and Px equal to Phx and Ym and M. Ym, that means average income of physician, that is mean income of physician, and M is number of physician engaged in hospital service. And I have already discussed PH, payment made to hospital. X is the number of stay in hospital. P is total price of hospital, and X is the number of stay in hospital. And now we have to derive average revenue function of physician under the Pauly Redisch framework. Before moving ahead in this video, for derivation of Pauly Redisch framework for average revenue productivity of physician, if you come first time, please subscribe my channel and hit bell icon for all notifications so that you can get my video notification easily. Now let us start derivation of average revenue productivity of physician. First you need to watch assumption number 6. Total revenue is distributed between hospital and physician, and equation Px equal to Phx times Ym into M. First write down the equation from assumption number 6. You can 6. I am taking this assumption number 6. Px equal to Ph x plus ym times m. Here we need to solve for this ym. It can be written in this form: phx plus ym m equal to px. Now shifting phx into RHS side, ym times m equal to px minus phx. Now ym equal to px minus phx. One thing, and divided by m. And one thing I want to clear, where x is function of L, M, L, M and x is the function of k. X is the function of L, M, K, that is 3 input, that is the output of hospital service. X is determined by 3 input. First, M is physician engaged in hospital service. L is the amount of other staff, okay, a staff non-physician like technician, compounder, nurse engaged in hospital service. K is the amount of capital. And one thing we have already seen, P is the function of x. Okay, and now you can see here the since P H x equal to WL plus CK, substituting this value here, now we get ym equal to px minus this term equal to WL plus CK, WL plus CK, and whole term is divided by m. And now ym equal to px minus WL minus CK by m. Next task, to set into first order condition FOC and maximizing ym, that is the mean income of physician, that is the average income of physician. And with help of this equation, just setting into the first order condition, we will be able to determine the optimal size of physician engaged in hospital service. And now first order condition, and now P is function of x. P is function of x. Here we need to have knowledge of derivative, product rule, quotient rule, along with the function of function rule, that is chain rule. First thing, FOC equal to taking the partial derivative of ym with respect to m, setting equal to 0. And this term, this is the equation we are going to taking partial derivative with respect to m. Here we need to apply quotient rule, because x is the function of m, first thing, and we are taking the derivative of this term ym. Derivative of first term, del px minus wl minus ck. Derivative of first function with respect to m times second function is m minus derivative of second function. We are putting it inside the bracket, del m by del m We are taking the derivative of second function with respect to m times first function px minus wl minus ck, and whole term is divided by a square of second function, that is m square. Now here we have applied quiescent rule of derivative. Now px, you can see here px, p is directly function of x and x is function of m. Here we need to apply product rule and setting equal to 0. Second term remain as it is. Here we are applying product rule of derivative. It is the first function, and along with the using of chain rule, derivative of first function we can't take with respect to m. We need to apply function of function rule. First take derivative of p with respect to x, because p is the function of x, and after that we take derivative of x with respect to m, because x is the function of m. Derivative of first function times second function is x, plus derivative of second function we can take partial derivative of x with respect to m, because x is the function of lmk, del x del m into first function, that is a p. And if we take the derivative of wlck, all these terms are constant, its derivative becomes 0, and this term is a multiply this m minus, if you take the derivative of m with respect to m, obviously we get 1, and here we can get only term px minus wl minus ck equal to 0. Now we can take this term del x del m. It is available in both places. I am taking the common. Del x by del m. Okay. Taking common, here we are left with x times dp by del p by del x, and here only p times m, and separating these two terms, m by m square, and here minus px minus wl minus ck by m square equal to 0. Just separating these two terms, m square cancel, we are left with m, and now shifting this term in RHS side minus this second term. So now it become positive if it reach on the RHS side. I am erasing to get more space. Now it can be written del x by del m. Just I am arranging this term, writing p first. Okay, p plus x time dp by dx del x del p by del x, first thing, and second things mm cancel, and here m only. This term, if I shift this term into RHS side it become positive, this minus become positive, Px minus Wl minus Ck by m square, and this 1 m square is a cancel here m. Now write down del x by del m and p plus x times del p by del x. M is already consumed, and here Px minus Wl minus Ck by m. You can see here this term, if you take the derivative of x with respect to m, that is number of physician, it represent marginal productivity of physician into this term is equal to MR, equal to this term is equal to A average revenue productivity, and if you multiply MPM into AAMR, it become marginal revenue productivity of physician equal to average revenue productivity, and this is the derivation of average revenue productivity of physician under the Pauly Redisch framework. Here the marginal revenue productivity of physician equal to average revenue revenue productivity of physician. This is the complete video on average revenue productivity of physician under the Pauly Redisch framework, and easily you can also derive the average revenue productivity of non-physician, that is the compounder, nurse, technician, pharmacist under the Pauly Redisch condition. Just you need to this ym, okay, ym solving this term with respect to now L, okay, and this is the complete video on derivation of average revenue productivity of physician under Pauly Redisch framework. And